This is a video on sketching the graph of a polynomial. The question states, sketch the graph of y equals x cubed minus 3x plus 3. So we're going to first find our critical point and our inflection point. To find the critical points, I take a derivative and set it equal to 0. So the derivative is 3x squared minus 3. And when we set that equal to 0, we get x is 1 or x is negative 1. If x is negative 1, negative 1 cubed minus 3 times negative 1 plus 3 is equal to 5. And if x is 1, then 1 minus 3 plus 3 is equal to 1. So I get two critical points, one at negative 1, 5, and the other at 1, 1. Now let's find the inflection point. I take a derivative, and the derivative of 3x squared is 6x. Set that equal to 0, and x equals 0. If x is 0, then 0 minus 0 plus 3 is 3, and we get our inflection point at 0, 3. Now that we have the critical points and inflection points, let's draw a table to get the shape of the graph. So our important numbers are negative 1, 0, and 1. So that cuts our interval into x is less than negative 1, x between negative 1 and 0, x between 0 and 1, and x greater than 1. And we're interested in the sign of f prime and f double prime. So first, the sign of f prime. F prime is 3x squared minus 3. If x is large, or if x is a very big negative number, then we'll see that the sign is positive. On the other hand, if x is small, then the sign is negative. So what I get is that it is positive for x less than negative 1. It's negative for x between negative 1 and 0, and x between 0 and 1. And f prime is positive for x greater than 1. For f double prime of x, well, y double prime is just 6x. So if x is negative, we'll get a negative second derivative. And if x is positive, we'll get a positive second derivative, as we can see in the table. Now let's look at the shape. If a graph has positive first derivative and negative second derivative, it's increasing but concave down. So the graph goes up but gets less steep. If the derivative is negative and the second derivative is also negative, then it's decreasing and concave down. So it goes down and gets steeper as we go. For x between 0 and 1, the graph is going to be decreasing and concave up. So it goes down and gets less steep. And if x is greater than 1, the graph is increasing and concave up. So it goes up and gets steeper. So here's my shape of the graph. Notice at negative 1, we've gone up and then down. So negative 1 will be a relative maximum. At positive 1, it goes down and then up. So positive 1 is a relative minimum. So now I'm ready to sketch the graph using all this information. And what I get is that the graph starts down, very steep, goes upwards, and then gets less steep until it hits the critical point at negative 1, 5, then goes downwards and gets steeper until it hits the inflection point at 0, 3, and then keeps going down but gets less steep until it hits the relative minimum at 1, 1, and then it begins to increase and get steeper and steeper and steeper. And there's my graph of the cubic polynomial, and I'm done with the problem.